Welcome to Channel 17, the Town of Colonie Government Channel.
All right, everyone, thanks for venturing out. It's not that bad out, but Dr. Jeff Carlson, he's been here a couple times. He did a review of Blink for us and Social Intelligence, and every time he came, people were coming up to me and go, you gotta have that guy back. So he's one of our best reviewers, and he's gonna talk about a book, My Stroke of Insight, A Brain Scientist's Personal Journey, and Dr. Carlson does brain research down at Albany Med. The Department of, it's always a mouthful to try and say, the Department of Neuropharmacology and Neuroscience, and if you go to the department's webpage, you can read his research. I can't even explain what it is, but you'll go read it. So anyway, here he is to talk about the book. The book's on the bestseller list, so she's on all the TV shows, so for once we got a bestseller, so here's Dr. Carlson.
Okay, there we go. I first ran into Jill Taylor's work on her stroke, talking about her stroke, 6 months ago. I think she was on the Terry Gross show talking about her stroke and talking about brain function at the same time. She's a neuroscientist who's interested in how the brain is put together. I just thought it was great. What she had to say was great. Became very intrigued by the fact that a neuroscientist was talking about the brain and basing a lot of what she said on her personal experience. And I said, well, I'm going to follow up on that. I'm going to find out all I can about that. And then Joe came along and said, hey, there's a book we'd like you to review. And it gave me a golden opportunity to think even more about Jill Taylor's work. Very interesting person. She had done quite a bit in brain science before her stroke. You'll notice she talks about herself as the singing scientist. Well, she was a singing scientist before she had her stroke, and we'll explain that in a few minutes. She talks about her brain scientist's personal journey, and obviously that's the journey she took in having her stroke and recovering from her stroke. And many of you have probably seen her on TV. She's been on Oprah. She's been on the radio, as I said. She also has a web page where she gives like a 15-minute talk about her stroke on a web page called TED. You might want to search on that, and you can watch that for her discussion of her stroke. Here she is. This is her now. This was about 12 years ago. Actually 12 years and a week ago. She was a 37-year-old neuroanatomist working at Harvard, very interested in how the brain works, particularly interested in schizophrenia. She was studying how the brain changes with schizophrenia, looking at post-mortem brains of people who had died, who had been schizophrenics, trying to understand that whole thing. She had a massive stroke when a blood vessel exploded in her brain on the left side. She witnessed many changes in her mind, okay? I'm a neuroscientist, so when I hear the word mind, I immediately begin thinking about brain, okay? The mind is how the brain works. We never would have said that, 100 years ago, but now we can say that because we're beginning to understand how the brain determines, what we think and what we feel and so on and so forth. She recounts her stroke and her recovery, and she is in a very, very unique position here because she has the insight about the brain based on not only her work, but the reason why she's the singing scientist is she's the spokesperson or a major spokesperson for something known as the Harvard Brain Bank. Now, the Harvard Brain Bank is involved with the research, and they are very interested in getting post-mortem brains that people donate. She's a singing scientist because she actually has a program where she goes around the country telling people that it's great to donate their brains to science for research. She's also very, very involved with the National Alliance on Mental Illness, or NAMI, which is a support group for the families of schizophrenics, mainly. Again, the Harvard Brain Bank is a place where scientists can have access to the brains of people that have died, not only from while having schizophrenia, but from other kinds of progressive brain diseases, for example, and so on and so forth. And a lot of what we know, not only about how the brain works, but how it dysfunctions in many kinds of states, is known because scientists can study these postmortem brains. Now, Jill's book is very much involved in the idea of brain asymmetry, that in some sense we have two brains in our head, one on the left side and one on the right side. If you see that picture, you see the front, and you see the left and right hemisphere, it does look like two things. And the two sides are connected by some fibers that go through the middle that connect the two sides. It's called the corpus callosum. Okay, so information does go back and forth between the two sides. But the more we learn about the brain, we realize the two sides are not really the same. They're very different in many ways. And when you have a stroke on one side, you're going to have one side of your brain sort of taking over and doing many of its functions, where the side with the stroke would not be doing its functions. So here we have an interesting situation. Here's the cover of Jill's book, and I thought I'd put it up there because it says a lot about Jill's journey. Right in the middle, you'll see a picture of the brain that looks like it's made from stained glass, and that's what it is. It's made from stained glass. Now, it's reasonably anatomically correct. Those different colors are meant to signify different brain regions that have slightly different functions, and we'll be talking about some of these slightly different functions. And I had hoped that when we enlarge this, you'd be able to read it, but it's a little bit hard to read. And let me read it to you. This is Jill Taylor talking. She said, "I now existed in a world between worlds. I could no longer relate to people outside of me, and yet my life had not been extinguished. I was not only an oddity to those around me, but on the inside, I was an oddity to myself." And this is a good statement that characterizes this personal journey that she took. She was a different person. She only had one side of her brain working effectively. And we're going to talk about that because what's happened with Jill since that time, since the time of her stroke, is that she's come back. And she is a fairly functional person right now. She's probably not 100% the way she was before the stroke, but this personal journey is not only a journey of injury, but it's also a journey of recovery. So I think it has a lot to say about stroke recovery in general, and some meaningful messages for people. I don't know, many of you have probably had relatives or know people that have experienced a stroke. And Jill's message of the possibilities for recovery, making the brain work again, is just a great message, and we'll talk about this message. I said the two brains are different, and this whole idea of brain asymmetry is not a new idea, and I like this because it's something I dug up a number of years ago. And what it is, it's a text from a medieval manuscript that was written in 1532, and there's the Latin up there for those of us who can read Latin. Some may be able to. But there's a translation down there. And the interesting thing was, even though it's in a medieval manuscript, its origins go back to the Greeks. Now, the Greeks seem to know everything, right? This guy, Diocles of Caristus, said, accordingly, there are two brains. One gives us understanding, and the other one gives us perception, okay? That is to say, the one on the right side is the one that perceives, and then the one on the left, however, we understand. And that is a pretty fair statement, because what happened in the case of Jill was she had her stroke on the left side. So a lot of her understanding of things that we see as very fundamental, a lot of that understanding was compromised. And we'll talk a little bit about that. First of all, let's talk about the right side of the brain, the side that wasn't damaged in the case of Jill. And many of the things I'm going to say about this are kind of oversimplifications, but nonetheless, I try to keep them as accurate as I possibly can. And this is the right brain, even though its direction is reversed. It looks like the left, but it's meant to signify the right. And I'm going to talk about some regions. The right brain is keyed to emotions, okay? It's our emotional side, okay? The limbic system is the area in the brain that is not really out on the surface. So these arrows are really pointing toward the inside of the brain, if you want to think of it that way, okay? The amygdala is an area where we experience fear and rage. And in fact, more recent work says we experience happiness through the amygdala as well, and joy. Hippocampus is a learning and memory area, and the cingula gyrus is an attention area. Now, all these three areas together allow us to experience and express our emotions. These areas communicate with other areas of the brain, okay? This area of the brain has been talked about as the lizard brain. And it's because lower forms of animals, all the way down to lizards and even beyond probably, really depend upon these brain regions as those regions that take care of what they do, how they perceive the world, how they react to the world. You know, they have some very fundamental things, like they know how to experience fear, they know how to go where there's good food to eat, and so on and so forth. They don't do much thinking, okay, in that sense. What's happened in development as organisms have gotten more and more complex is they've taken that lizard brain and it's gotten more complicated in the sense that cortex, area on the outside of our brain, has kind of developed over that, okay? And when you get to the mammalian brain, you'll see that that lizard brain is in the middle, and out around the outside of it is the cortical brain, the human brain. Brains of apes, brains of even dogs and cats are much more complicated in that they have cortex. That cortical development has really come to its extreme in sophistication if we look at the left side of the brain, okay? If you look at the left side of the brain, you'll see that some very specific areas of the left side of the brain are involved in things like communication, speech creation. 100 years ago, over in France, a neurologist found that patients who had lesions in what's known as Broca's area, Paul Broca was the neurologist, said, you know, these people have a hard time creating speech. They can't pick the right words, and so on and so forth. Wernicke was a German neurologist who showed that when this area of the brain was damaged, people had a hard time with understanding speech. Parietal cortex, attention to the physical world around them, being able to focus on things and so on and so forth. Damage in there causes those kinds of problems. You see motor movement areas and sensory areas are also very much tied up with all of these areas on the left side. Again, an oversimplification, but nonetheless, these are key elements of what happened to Jill when she had her stroke. And basically what I've done is I've taken this red oval and thrown it in there because she had her stroke on the left side, and this is where all the damage ensued. So taking those two diagrams, I think we can put together kind of a summary of what happens on the left side and what happens on the right side, and then we can begin thinking about what happened to Jill. The left hemisphere, it thinks in a linear and methodical fashion. Very good at problem solving, very good at deciding in a step-by-step way where things are going, where things have been, so on and so forth. It looks to the future, it looks to the past. It organizes and categorizes information, puts things into slots if you want, and so on and so forth. That's our left brain. It thinks in language, okay? It works, for those who want to think about a computer analogy, as a serial processor, more or less one thing at a time, taking steps. Okay, left side. The right side is very different. Remember, the right side kind of thinks the way a lizard does, okay? It thinks holistically. It lives in the moment. It doesn't think about the past. It doesn't think about the future, right? It's a collage of energy streams is the way Jill describes it, okay? It's just energy coming in, there for the present, sort of like an animal, a cat. You know, a cat doesn't anticipate what's going to happen the next day. He's there in the moment. You know, we all have pets, and even dogs are that way. They'll learn things, but nonetheless, they're not thinking about tomorrow too much, right? Jill says a few other things that she kind of began talking about because she was able to experience her right brain a lot more so than most people because of her stroke on the left side. She said that we're kind of connected. This living in the present, this collage of energy coming in, kind of connects us with everyone else. Because self-identity is really over on the left side, okay? So it's sort of like one of these ideas of one with the universe type thing. When we experience the right side, she makes a big deal out of that in her book. You're in the moment, you're perfect, you're whole, and you're beautiful. And that's the way she says she felt, okay? Works as a parallel processor, okay? The idea that all this information is coming in all at once, it's all lumped together, and that's your experience. It doesn't think, well, there are paintings over on this side of the room, and there are more over here, and I can pick out the individual paintings. It's hard to do that with the right side of the brain. There's a holistic image. The right side of the brain sees the whole room at once and really has a hard time discriminating the separate pieces of the brain. Okay. That's also why the right side of the brain has a hard time discriminating self from all the people around. You get the idea? The holistic image is what the right brain gives us. So what happened to Jill? Jill had a stroke. And there are a number of different kinds of strokes, okay? The most common kind of stroke is the ischemic stroke, which is really a clot. And you'll see there's that little diagram up there. Those are blood cells flowing through vasculature, the veins and arteries. You'll see what happens there. There's a blockage. Now, the brain requires lots and lots of energy, okay? In order to get that energy, it needs oxygen. It needs oxygen that's carried to it through the blood. So what happens when you have a clot, the blood stops getting there, simply enough, right? And ischemia is basically brain damage. The neurons are not getting their oxygen, and they begin dying, okay? So with the ischemic stroke, the important thing is to get that clot out of there, okay? And neurologists are very, very interested in getting patients to the hospital as quickly as they possibly can in the case of an ischemic stroke, because we now have drugs available, for example, that allow us to break up those clots. There are also other ways to break up those clots and limit the amount of brain damage. And there's a lot of interest in promulgating the idea that, you know, you're gonna get to the hospital really quick if you think you're having a heart attack. Well, it's just as important to get there when you're having a brain attack. That a stroke is really a brain attack, and again, something good can be done for you if you seek medical attention right away. Part of Jill's book involves talking about how you feel when you're having a stroke. And, you know, that's one of the great things she's done. You know, being a spokesman for the brain, her stuff as talking about schizophrenia, you know, before the stroke, has really made her into the type of person that wants to go out and talk to the public. And that's why she's on, you know, Oprah and on the radio and everything, to sort of promulgate the idea that when you have a stroke, there's something that can be done for you if you seek medical attention. And she's been very good at doing that. Now, it turns out that 83% of strokes are ischemic strokes. And the other 17% are hemorrhagic strokes. Now, a hemorrhagic stroke is a break in a blood vessel. You'll see over in the corner there, you see the blood vessel, you see the blood flowing through, and you see how it's sort of ballooned out in one little area there. That by itself is okay, but what happens when it breaks is the brain, the neurons in the brain started getting surrounded by blood. And you can think of the neurons as kind of drowning in that sea of blood. Okay. Now, that in itself won't kill the neuron immediately, but it's not a good thing. You try to stop the hemorrhage as best you can there and keep that progression from happening. Some brain damage will happen in this case as well. Now, what happened with Jill was something a little different. It was a type of hemorrhagic stroke, but it's a relatively rare form known as the arteriovenous malformation, which is in some part genetically determined who has these malformations. What it is veins and arteries are blood vessels. The artery is under high pressure, pumping blood around the body, right? And what happens is that high pressure blood goes all around the body, goes through these little capillaries and everything, and it loses pressure before going back to the veins, okay? The veins are not made to handle high pressure, okay? So everything is okay if the blood first goes through these little vessels where the pressure gets reduced. However, if you have an AVM, you have a malformation in this, so that the artery is more or less connected right to a vein, okay? And what will happen there is a person generally will live generally into the 30s or 40s with this, and in many cases they never know that this malformation is there, but something can break. It's sort of like a garden hose that gets too much pressure and just bursts, okay? And that's what happened in the case of Jill. This didn't reproduce real well. Over here is something from the Mayo Clinic, which is actually, this is an angiogram. They can put a dye into the blood vessel in the brain. This is the break right here. And you'll see arteries and veins and a break happening right in here, and you see all that ballooning out. What happens is the neurons in that area start swimming in blood, okay? Things can be done to stop that process. So this hemorrhage can be stopped, but then the goal is to get that clot out of there and try to retain function in the brain. And that's what happened with Jill. About a week after her stroke, she went and had surgery where they actually went in and took that out, and then her process of recovery began. Now, it's very instructive to read through the book and learn a bit about how the two sides of the brain worked, and Jill's experience of having the stroke and all the things that happened during the early part of her stroke experience are very interesting to read, because you learn, first of all, what happens to a stroke victim, but also how the brain works. She's talking about the two cerebral hemispheres, how they'd work together and allowed her to do all kinds of things. Suddenly, when she had the stroke, she felt disjointed. Her linguistic and calculating skills on her left brain were no longer there. Where were her numbers? Where was her language? The left side of the brain had gotten turned off. Secondly, she said, what had happened to the brain chatter, which was now replaced by a pervasive and enticing inner peace? She felt stuff from the right side she didn't have all this language and thinking about the future and the past and everything. Influence. She called it chatter. So she talks about it almost as a nirvana state, which is kind of interesting. We'll talk a little bit about that idea before we're done. Her object recognition and her symbolic activity, her math ability were all compromised. When she knew what was happening. She was a brain scientist, obviously. She knew how the brain worked. She knew there was something wrong. She knew she was feeling things differently than she'd ever felt before. So she said, well, I have to call somebody. She needed to get the number. Now, even though she should have known the number, she wanted to call people in her lab at Harvard to say, hey, I need help, okay? She found a number. She looked at it, and she saw a 2, but she didn't know it was a 2. It was a squiggle. What does that squiggle mean? Remember, her language, her math ability was all gone. She drew the squiggles, and she said, it's got to be part of a number, this 2405. But somehow she knew it's only part of a number, because it's only a small set of squiggles, you know? And here she's got to dial this number somehow to get help. She didn't know what to do. Fortunately, by matching the squiggles on that list with the squiggles on her phone, she was able, with her compromised motor ability, to get the number pressed. And she got somebody on the phone at her lab. She heard him speak. She couldn't decipher his words. She knew he was saying something, but he sounded like a golden retriever to her. Remember, her language was gone. Her ability to understand speech was gone. And then she blurted out, "This is Jill, I need help." Okay. Well, that's what she tried to say. A couple of grunts came out of her mouth. Okay. Fortunately, the guy that she contacted was a close associate who understood Jill's voice, or at least had used to hearing Jill's voice, knew who it was immediately. And, you know, this whole idea of not being able to produce language and not being able to say anything intelligently was really vividly portrayed by Jill's writing. So her left hemisphere did not know what was going on, but the soft tones in her voice and so on and so forth really meant a lot to Jill. Her right side was experiencing all the emotions associated with hearing somebody who really wants to help you, especially when a close friend wants to help you. You know, when we talk to our pets, you know, we like to think that they really know what we're saying. But in many ways, they're responding to just this kind of thing. Remember, our pets are relying on their right side a lot more than we are, okay? And same kind of thing, responding to emotions. Some of the highlights. Great description of what a stroke does. Okay, this whole idea, this early stuff about what happens during a stroke, everybody should read that. Anybody who has the possibility of either having a damaged brain or dealing with a person who's had a damaged brain can get a lot of insights into that whole process. She gives a very lucid and a very engaging description of functional neuroanatomy. In other words, what are the parts of the brain, what do they do, and so on and so forth. She talks about her surgery after the stroke. Very informative. Where you realize that there are people in the hospital who've been through this with other patients and are really great at being able to intervene and really know how to intervene. Now, she was at Harvard Hospital or Mass General, the Harvard Hospital, where she had some of the best stroke people in the world. And her experiences in dealing with these people are really, really kind of interesting to follow if you read through that section. One of the great things, though, in the book was her left brain re-education process, okay? Her mother lived in Indiana, came to Boston, and moved in with Jill and began helping her. One of the first things her mother did in helping Jill bring back that left function was to work with puzzles, where she would give Jill puzzle pieces, and Jill would have to learn, what the top is and what the sides are, and how to fit pieces together, how to fit interconnecting. Everybody knows how to do puzzles. Well, the funny thing is, over on the side, we see that stained glass. It's probably not too surprising that as an artist now, Jill is very, very attracted to putting together puzzle-like things like stained glass pieces and so on and so forth. The nice thing about it is, if you go through that section of the book, you realize that this recovery process is really a step-by-step process where you start almost as a child and you begin re-educating. The gratifying thing is that you see, from Jill's experience, how plastic and how changeable the brain really is and how far along you can take the brain. What's happening in Jill's case is that she had many neurons that she used to use to do these things that were killed, okay? But the brain is capable of substituting other areas to do the same kind of thing. But those other areas simply have to be taught how to do these things. And that is all vividly portrayed in Jill's book, that brain re-education is such an important part of recovery from a stroke, okay? She's got appendices where she takes a lot of the things that you can pick up by reading the book and summarizes them. She has recommendations for recovery. What do you do with a stroke recovery patient? It's really great set of recommendations. She has assessment questions, how you follow what's going on. 40 things I needed the most, okay? She has a list of things that she needed from others in order to make her recovery happen. And it's really great, because I think these are things that any person recovering from brain damage can really profit from hearing about, okay? The warning signs of a stroke. Obviously, we need to identify strokes as quickly as possible to get the process of recovery started, and those things can not be said enough, and she's got a really nice section in there. One of the very interesting things that she said about her recovery is that as her new left side was developing, okay, during the process of recovery, I found that the portion of my character that was stubborn, arrogant, sarcastic, and or jealous resided within the ego center of that wounded left brain. She said, this portion of my ego mind held the captivity for me to be a sore loser, hold a grudge, tell lies, and even seek revenge. Reawakening these personality traits was very disturbing to the newly found innocence of my right mind. Okay? With lots of effort, I've consistently chosen to recover my left mind's ego center without giving renewed life to some of these old circuits. Okay? Very interesting idea. I don't know. I think she goes a little bit overboard at times.
I believe her.
You believe her? Okay. Because by the end of the book, you almost get the feeling that the stroke was the best thing that ever happened to her. Okay? And, well, maybe it was. Okay. Certainly an intriguing idea. But I have some questions about the book. The thing that kept bugging me all the way through reading the book. As you know, was I got really excited during parts and say, yeah, that's just what should happen. You know, oh, that's interesting. Yeah, oh yeah, oh, that part of language should break down first, and then this part, and I was thinking, oh, that's great. You know, facing the whole thing as a neuroscientist, but you know, oh, sorry about that. How did she remember all this? And you know, I got the feeling that in some ways I was reading a neuroanatomist interpretation of what happened during her stroke, which I'm sure she kind of filled in because she knew what was supposed to happen too. So I don't know. I just wonder about that. You know, she describes her early post-stroke experience as nirvana. You know, her right side had taken over, you know. And she said, oh, I was in La La Land. I was very happy and wanted to stay there. In fact, there's a lot of times when she talks about trying to get help and saying, nah, I'm enjoying myself this way. I don't need help, you know, which is a little bit disturbing because that's not what happens with everybody who has a stroke, you know. As a matter of fact, there is a psychiatrist at the University of Iowa who spent his career looking at depression in stroke victims. Many survivors of stroke on the left side fall into a depression, and not happy people, okay? Now, sure, most of these people are ischemic stroke, where, you know, there's a lot more brain damage in many cases, okay? So, you know, maybe with certain kinds of AVMs, that's not going to happen, but I don't think nirvana is a good way to characterize the after or the sequelae of a stroke, okay? Maybe some people will experience that, but certainly not all. And, you know, I think you can go a little bit overboard in encouraging stroke survivors by saying it's the best thing that ever happened to me. You know, it's good to take a negative thing and turn it into a positive, and there are many positive aspects of a stroke, but I think she, at times, may go a little bit overboard. I think her last statement, and this is not in the book, but it's something that she said in one of her ending one of her talks. I think it's on the website. She said that she had a lot of insight about the right side of our brain, and she talks about being able to choose the right side of her brain and how we don't pay attention enough to our right hemisphere, and that everybody should pay more attention to the right hemisphere. In fact, the last third of the book is all about the right hemisphere and how great it is and how, you know, peace and brotherhood and love and all that stuff has to be part of our daily lives, which is a good message. And she says, which would you choose? Which do you choose? And when? I believe the more time we spend choosing to run the deep inner peace circuitry of our right hemisphere, the more peace we will project into our world and the more peaceful our planet will be. And I thought the idea was worth spreading. I think, you know, that's true. And there are many ways to do it without having a stroke, obviously. But, you know, it's a good message for those who like such messages. There are many ways to do it. Let me just mention one. Language resides on the left side of our brain, very important form of communication. Well, it turns out that the right side of the brain also participates in language. But what the right side of the brain is more involved in for language is in producing the emotional content of language, so that we can express a lot through our voice by simply a voice inflection. Certainly by listening to a person's voice, we know how that person feels. We know whether he's surprised, whether he's happy, whether he's sad, and so on and so forth. As a matter of fact, there are languages that totally depend upon inflection to convey information. Chinese is a good example of that, where it's a tonal language, okay? Because the right side of our brain is very, very sensitive to that kind of thing. the ultimate expression of language comes in music. Music is a kind of language that conveys emotion. You get the idea? As a matter of fact, there are many stroke victims who have stroke on the left side of their brain that don't talk very well, but can communicate through singing. Okay? And music and singing is a way of imparting even more information. And that's one of the reasons why Jill became the singing scientist. Because she has these little tunes that she sings for people when she advertises the brain bank. Get the idea? Okay, I think we're done, and we'll leave that up there as our last picture. It's been a talk about the brain, and I guess we can talk a little bit about some of these things. Yeah.
Might have a lot.
Yeah, go ahead.
When I see your description of the left and right brain, I also see a description of the conscious and subconscious. Can you speak to that?
Yeah, there are many ideas like that. Freud talked about the id and the ego, and you can think of the left brain as being ego and the right brain being id if you want. Conscious, subconscious, it could be, yeah. We don't...
I think of brain waves when I think of conscious and subconscious, the beta, the alpha.
Yeah.
So are you saying that the left brain is the beta, and when I go into my alpha, I use more of my right? Is that what you're saying?
Yeah, except that normally the two sides have to work together, okay? And it would be nice to say that we're turning on the right side when we're meditating or going into one of those, states of, and I think that's kind of true, but it's not like we're turning one side on and the other one off. I think we're using the inputs from one side more than the other, maybe. But again, our brain is still connected. The two sides are still connected, so it's not that abrupt a thing is going from one side to the other. It's hard to be specific there. Yeah. I'm just going to go in a circle. Okay. Yes.
Reading this book
Yeah.
about a left side stroke made me wonder what would it be like if a similarly massive stroke had struck her or someone else's right brain. Is there any literature on the subject, either systematic or anecdotal? Or if not, would you care to speculate? Would we have a Dr. Spock sort of character?
Well, we actually have somebody here who can speak from personal experience, and that's better than anything I can say.
Well, 2 years ago, my mother had an AVM on her right side. And as I'm trying to convert everything she says from the left side to the right, she's got a lot of medication to keep her. She went through very anxiety, paranoid. I mean, she lived in that left side only, and it was a very extensive damage on her right side. She is still very memory impaired and actually in a nursing home, but everything else about her is healthy. And I think through medication, she's happy, but the anxieties and were without the medication was incredible. She's impulsive. She has no attention. It's very hard. And reading the book, I was just hoping that there was still time to improve. It's been 2 years, and we see little plateaus every once in a while. But we keep trying to bring her into the positive. But so she can remember. She didn't remember her house of 40 years, but she remembers more of where she grew up. She'll know that when you ask her about her kitchen, because we're Italian, and that's what she remembers. Sometimes I go in and I wonder what decade she's in, because she'll start talking about someone's wedding, and I'm like, they've been married 15 years, but she's living in it. She's not just she's not visiting it, revisiting it. She's living in it. So it's always a different.
Well, to translate that into brain science a little bit, and I hesitate to, because it's hard to do this, but.
No, please do.
But, it's sort of like the areas of her brain on the left side that sort of filter through all these things, all these positive things that she responded to on her right side, is still there. But it's not sorting through the same things it did before, because that right side is damaged. That's the best I can do with that. The problem is that the left side is fairly well understood because we know the rules that are followed by language and mathematics, and when they break down, when the left side breaks down, it's very easy to say, well, this person can't recognize the number 2 anymore, and so on and so forth. When the right side breaks down, we don't, it's harder for us to talk about the right side.
It's more psychiatry in a way.
Well,
dealing with the
yeah, but it's like holistic things. It's hard for us to think in terms of parallel things all converging and being something. Like I can talk about all the elements in this room, but it's hard to describe the room as a whole. I can say it's a room with pictures, but as soon as I say pictures, that's one of the elements of the room. So this whole Gestalt, the Gestalt psychologist, for example.
Social appropriateness is which side of the brain is that? Because that was also an issue. She's uninhibited, a little more now. I mean, in speech, more so now. But I mean, she'll say whichever she's thinking, which is not the way she was.
I don't know. I really, I hate to speculate too much, but that's all I can do is speculate about most of these things.
She loves her cliches. I mean, she'll come out with one cliche after another. She's very funny.
It's the problem with the brain. It's a problem, but also it makes it very exciting. We know so little about how the brain works. I mean, we can go through all this, but we're just touching the surface.
In the recovery, for example, in Jill's case, when she was recovering function, were parts of the damaged side actually reconnecting in the damaged tissue in the brain, or was it other parts of the left side taking over for that?
Probably more the latter. Probably.
Okay, because once it's damaged, it's dead?
Well, once a neuron is damaged, yeah. But the whole thing with the brain, the way it works is it's like these networks of neurons, okay? All interconnected and sort of reverberating back and forth with each other. So like some of them can be damaged, but others not. And there's the possibility of new connections forming with the ones that are not damaged to other brain areas. So that's kind of the way it works.
And one other comment, what my impression of the book, which I really enjoyed very much, was her talking about that euphoric state. And I thought maybe it was just because she was a brain scientist and knew so much about the brain that she could actually enjoy this to some extent.
That may be true. That may be true. And it was a unique personal journey, and part of her uniqueness is the fact that she was a brain scientist.
What was happening probably as she
so was fascinated by it, whereas other people might be totally frightened by it.
Does she talk at all about physical paralysis?
Yes, she does. Moving her arm.
How much of that came back?
All of it, from what I could tell. If you could get to that web page, you'll see she looks like a perfectly functional motor system. She didn't have a list on one side even or anything. So motor system came back.
Because I know somebody who had a stroke on the right side and it's the left side.
Oh yeah. Well, that's the other thing. There's crossover. So the right side controls the left side and so on and so forth. And presumably we have a dominant left side, and that's one of the reasons why so many people are right-handed, that kind of thing. Although that's not necessarily true, but it's kind of true. Okay, that kind of thing. Yeah. Yes.
What is the difference with the schizophrenic brain?
You've asked if there's any illness that we understand the least. All the psychiatric illness is schizophrenia. And it probably has to do with something that is initiated almost at birth with brain development, particularly with cortical areas, involving neurons that just don't develop the way they're supposed to. That there is probably genetic contribution to it. But it's also highly dependent upon environmental experiences. And we can point at certain types of cells in the brain that don't develop the right way. We're beginning to understand more and more about schizophrenia. But again, it's one of the least understood.
Does
things
it get
are.
worse with age? I mean, I know somebody that's brilliant who has schizophrenic traits. They seem to be getting worse
Yes.
after 60. He's never been
Oh,
treated because he
60.
doesn't,
Yeah.
he doesn't deny, I mean, he doesn't accept that there's anything wrong.
Yeah.
And he switched from writing wonderful rural stories to, two pins and vibrating strings and,
Yeah,
like
yeah.
out of the brilliant mind.
Yeah.
But it does seem to be getting worse.
Yeah. Well, as we get older, we lose some capacity. And it may well be that he's been compensating for a lot of these things in ways that he's not able to do anymore. That's all I can.
He fires
It's all
off angry letters
speculation.
to newspapers. And
Yeah.
Yeah, there's a lot of that.
Yeah, I can only speculate. But that's all I can say about that, really. The brain is a very interesting organ. That's all I can say. Yes.
What research is being done to help prevent strokes, and are there things that we can do to make sure our brains are as healthy as possible,
Well,
including diet?
keeping our blood pressure down is probably, obviously a good thing. And, eating a healthy diet and, all the good living type things, getting plenty of exercise, but also, being aware of the symptoms of stroke.
Could you just, I'm sure they're in the book, but could you tell those of us who haven't read the book yet, but how we might know that?
I would hate to go through that because there are some very specific things that a doctor, an MD, will tell you. And I hate to kind of represent myself that way, and they're all over the place. I'm afraid I might miss some things if I tried to go through them now. I have a general idea, but I just can't rattle them off. Sorry. Yeah.
This business of Jill's left brain hemorrhage, and then she came back by doing puzzles and that sort of thing. Would that work with the right brain hemorrhage and left paralysis? Would doing puzzles and that sort of thing work to rehabilitate?
It could to some extent, because we have to remember that even though we talk about the two sides as being different, they work together. So yeah, it could. It should work. General, the best thing you can do with your brain is engage in many types of problem-solving activities and thinking activities and so on and so forth. Because every time we do that, we're forming new connections. So, if you have damaged connections, the best thing you can do is to make your brain establish some new connections, keep active, approach life with a bit of wonderment and saying, I'm going to find out about this. I'm going to learn all I can here. Doing puzzles, crossword puzzles, picture puzzles, anything to keep your brain active. And people even say that about aging. I mean, even without a stroke, keeping our brain active is one of the best things we can do for longevity. So it's good to keep the brain growing and functioning in general. Yeah.
Does the author say how she got the right part of her brain to take over the functions of the left part? Definite steps that she took?
Well, I think she had no choice, right? Yeah, the right side of the brain was functioning for the longest time without input from major areas of the left side. So, that was happening naturally. And I think what she tried to do was get the left side to come back. So, she didn't have to try to get her right side. In fact, one of the best parts of the books is when she's talking about how great it felt to just have that right side working. Interesting idea there. That's her nirvana state that she was in. Yeah.
Questions?
Yeah.
I wonder how much of this emphasis on rationality of the left side is culturally based. Are there cross-cultural studies of, say, India?
That's an interesting observation, and I wouldn't be surprised to find out that is true. I don't really know specifically of anything I can point to say that it is true, but it's a very intriguing idea.
What was it?
Cross-cultural things. That some cultures use the right side more. I think it probably. I think it probably is true. I think I better stand this way, huh?
Oops.
Yeah, we just lost some neurons. Yeah, right. Yeah,
Two-part question in regard to Jill.
yeah.
I assume that by this time she's completed all recovery of the left side of which she's capable. And did she get to the point where she could resume her professional career? And if she did she so choose to do that?
She was a brain scientist at Harvard, working full-time, probably working 16-hour days and all those other things before the stroke. She is now at Indiana University as an adjunct professor, which has a lot less demands, obviously. She's also really big in giving lectures and on lecture tour. She's also very big in the brain bank and the Harvard brain bank and the singing scientist type of thing. And also very big in still working for the National Alliance for the Mentally Ill. So she's keeping active. So it seems like she's still doing a lot, but maybe the rigors of a full-time job at Harvard are a little bit too much for her. That's my guess.
But in terms of basic intellectual skills
Yeah.
that were required before, did she recover? How well did she recover the capability?
I think in the book she sort of says she's not 100%, but she's
relatively
pretty close. Yeah,
Pretty close,
yeah. So she's done quite a bit for recovery. Yeah.
I assume her website that you referred to is in the book?
I think it makes reference to it. Yeah.
Do you know off the top of your head what the website is?
I think if you Google Jill Taylor.
Visit her drjilltaylor.com.
Oh, okay, thank you.
There you go.
Yeah.
Okay.
JillTaylor.com.
JillTaylor.com.
Dr. Jill.
Yeah.
Dr. Jill.
DR. Yeah.
It's about localization and function.
Yeah.
Where are memories stored and processed? And would different kinds of memories be stored at different places?
Different kinds of memories will get stored in different places. Hippocampus is a major memory area. Okay. Amygdala, fear memories. Cortical regions are.
Well, we better.
Sorry. Cortical regions communicate with these areas and are very important in memory as well.
Let me just turn that down.
In some sense, memory is all over the brain, but they're very specific areas that are kind of channeling areas for memory as well.
Will they be related to the various, like knowing how to speak might be a Broca's area?
Yeah.
Knowing how to do certain music links might be located in the right frontal.
Yeah, music links are certainly right side, communicating with the left side. But that's different. Trained musicians probably rely much more on the left side for music than untrained people who just listen to music. So the thing is, everything we've talked about in terms of brain function is kind of a general statement, and the fact is the brain is so plastic that function can differ slightly from individual to individual. Yeah.
And my mother did play the piano within 2 months after.
There you go.
Just totally by rote,
But she played before too.
She played before, right. But I mean, she sat down and just, it was almost as though she never, the keys weren't always right or whatever. And that started actually, she couldn't do it as much as I went on. But I do have two questions that Jill said. Jill said she had migraines her whole life and that they attribute some of this to, my mother had migraines her whole life, and I was wondering what you thought about that.
Well,
migraines.
I guess that's true. I hadn't really thought about AVMs that much before reading the book, but it would make sense that blood vessels there are not functioning properly, and there's a whole lot of pressure in places where there shouldn't be a lot of pressure.
But
the amazing thing to me is that your mother didn't have that stroke until she was in her 70s. Now remember, Jill was 37 when she had hers, and that's sort of talked about as the age where this kind of thing happens.
Yeah, she does have low blood pressure, so maybe that was.
Well, maybe that's it. Yeah.
But I think migraines tend to be what bilateral. This was definitely over her right eye. She was. Within hours, she was in pain, and I often would love to ask her, because Jill described her few hours when she was home.
Yeah.
That leads me to my second question: is surgery. Now, my mother had surgery within hours after getting to the hospital, and that really is why she survived. Jill didn't have it for a week. How did it clot that quickly for her? I mean, how did that?
I think that's probably what happened, but I don't know specifically.
She says it clotted, but I thought
Yeah.
that you didn't survive unless you had it.
Immediate surgery.
Immediate surgery.
Yeah,
That's what
apparently there was enough that it stabilized there
Yeah.
to allow them to wait.
Yeah.
And I'm not sure of all the details and all the decisions
She
that were
didn't
made
have the
there.
ischemic.
Huh?
She didn't have the ischemic.
That was not an ischemic stroke,
That
right.
would explain part of why.
Well, that's, yeah,
My
well,
mother had the AVM. My mother had the same.
yeah, these are both
on the right
AVMs,
side.
yeah.
Yeah.
Yeah, yeah.
All right, well, thanks for coming again, Jeff.
And I really
Welcome to Channel 17, the Town of Colonie Government Channel.